Hello everyone and welcome back to another book review. Today I'm going to be reviewing Illustrating Mathematics. This was edited by Diana Davis and this is what the cover looks like. So I have a long-standing interest in how math can be visualized and illustrated in art and the connected nature of those two fields despite not seeming connected at first. I've read plenty of interesting books on this topic, including one called Math Art, which kind of really kickstarted my interest in this. And so when I found this book in online catalogs, I decided I wanted to give it a read. I ordered it to my library and I read it and I have thoughts on it. So I'm going to talk about what you can expect if you get this book for yourself, what's in it, as well as my favorite pieces of art that were featured in this book. So this book is not necessarily a single artist presenting their pieces, but instead it seems to have stemmed from this meeting that took place in 2019, the Institute for Computational and Experimental Research Mathematics, or this ICERM, which occurred in fall 2019, and it was part of the Illustrating Mathematics programs. So at the very beginning, we have a picture of the participants. And it seems to be that this book is a collection that's been edited by the editor, Diana Davis, to showcase the outcome of that conference, or people who met up, or the outflowing of creative energies from that conference. So the works are arranged in general categories or by medium. So there are drawings, paper and fiber arts, laser cutting, graphics, video and virtual reality, 3D printing, mechanical constructions and other materials, and then a final section which is labeled multiple ways to illustrate the same thing, which is where an artist takes one concept and does multiple iterations of ways that we can visualize this concept. There is no overarching theme of what math topic is being illustrated, so it's not just all geometry or all algebra. There's a wide variety, and it seems that the people were free to select what they wanted. Also, not every artist is featured just once. We do have repeats as people submit multiple pieces of work. The setup besides the general section is once you get into a general section like drawing, you'll have an introductory page like this. And then each page or each set of pages includes the artwork on this side. So the artwork is always on this side. And the person who did the art over here, which includes their name and their affiliation, and something they've written about the piece, which mostly starts with the math that's being depicted here and what you're expecting to get out of it. And a lot of the artists also talk about the challenges that they experienced while creating this piece of art. Also, often, but not always, there's links at the bottom for you to pursue further information, which I found really interesting and a great way to spur further interest, because each artist and each piece of, not each artist, but each piece of art is only getting one page like this. So if you want to learn further or go deeper, you're going to have to use those links at the bottom. The artists do start with an assumption of knowledge, so there's not a lot of hand-holding because the artists aren't here to explain the math to you. They're here to showcase their visualization of the art. Some of it seems quite basic and something that most of us can grasp, but a lot of it is quite difficult or complex mathematics, at least for me. And I am not a beginner to math. I do have a degree in math, but the artists usually jump right in with an explanation of what they're visualizing, and I would tell you that if you feel off-put by this, maybe just don't assume or don't go in trying to understand the math behind it. Try to appreciate the art, because later on in the book, an artist makes a good point, which I'm going to come to at the end of me showing you my favorite pieces, which kind of shows how we don't necessarily, or understanding the mathematics isn't necessarily always the goal. Sometimes if you start with the art piece, you can learn things about the math that you are trying to learn. But the authors or the artists do have a very diving in way of starting all these essays, and I can read a couple of these for you, and you can see exactly what I mean. So diving in, having never heard about any of this before, this essay starts with, while studying properties of graphs and complex functions, specifically level curves of the real part of iterates of complex functions, we stumbled across blah, blah, blah. Diving right in, complete assumption of that you're going to understand what's going on. Here's another one. We are making paper with constant negative curvature in order to demonstrate various features of the hyperbolic plane. Now that one, of course, I understand, but someone with no knowledge might be a little off-put by that. But I would argue, try not to be off-put if you don't understand the math. There was plenty of math in here that I didn't understand, or I understood the words independently but not together. But I found the art to be really, really cool. The pace is fast, and if for whatever reason you start reading this book and you think the pace is a little too quick, I would actually suggest going to another book I reviewed called Math Art, which I will link my review for in this video, and starting there, because that's a little bit easier to digest and doesn't have quite the fast pace. Now that I've given you a little review of what you can expect if you get this book, I'm going to show you some of my favorite pieces in this book. And I will give you the page numbers, so if you're following along at home, you can come along for the ride. The first is on page 23, or the essay is on page 23, I guess. It's these cool little balls. The artist here, Edmund Harris, is associated with the University of Arkansas, and I felt like his work was really cool. I saw him multiple times throughout the book, but this is what I mean, where sometimes you can just look at the art and enjoy it, and then take what you can from the section that the artist/mathematician talks about. I should also add, as we go through, these are primarily people who seem to be associated with math or computer science departments, but there are also just artists who are participating, and those essays seem to be a little bit more accessible. So here's one. This is by Heidi Robb and Peter Benson at Cherry Arbor Designs, LLC. They have this tessellation here, and these are made from interlocking wood parts. And this is another place where I saw a cool connection between art and math, where these ostensibly probably artists are talking about a mathematical concept, these tessellations, here, and they've made it out of wood because they find that wood is a very warm material that people like to interact with, which is something that I saw again and again throughout this book, where people who are trying to illustrate a mathematical concept are thinking about what makes sense artistically. So there is this overlap between math and art continuously throughout this, but this is really cool. These are made from interlocking wood pieces, and I spent quite a bit of time looking at this one. The next is on page 39. This is a similar tiling of congruent pieces by Diana Davis, who is the editor, and these are made out of little lizards. You can see how they click together, and she talks about some of the properties that she discovered while doing this tiling in her essay. The next is on page 49. This is actually the graphics section, which is quite interesting and talks a lot about fractals. So this is a section you're going to want to go to if you know you have an interest in fractals. And we see this very famous drawing just on the, or illustration just on the front page of the section. We can see quite a bit of interesting fractals within this section. The next is on page 57, which the authors, I believe, or the artists, have a coloring book of this. At least that's what it seems from this section, because these would be very fun to color. They talk about how they're building these and the connections they found, but really the coloring aspect of these would be very satisfying, and I really liked the patterns formed here. This is, according to them, again, studying the properties of graphs of complex functions, but don't think you need to understand complex functions to appreciate this. And if you do want to better understand complex functions, then you can also appreciate the art that goes with it. Next is on page 65. This is one of my favorites. This is a tiling of a hyperbolic plane in various different projections, and this is by Matt Zucker. This page is probably my favorite. I love the colors that you can pick and the different tilings that he chose, particularly this one right here. Page 69 includes the art, which is interesting, but also a nugget that I wanted to discuss. So this talks about these knots and how you can go in these knots to go to different dimensions. That's kind of the idea that he's playing with, and he does have a good essay which explains things quite well. And he has these demonstrative knots in which you can go in and you can see the different perspectives. If you get the book and spend some time studying it, or you can just pause this video, you can really understand what's going on here. But in this section, there is a part that seems to hint to the continuity of mathematics. So he says in the third paragraph, to create this virtual reality experience, because this is in virtual reality, I had to learn a lot about cyclic branched covers of knots, as I had to construct them in the software implementation. This led me to discover a construction from Paul Heergaard's dissertation from 1898 that could be implemented to simulate these portals in virtual reality. And I think this is a really good demonstration of how math really builds on what came before, in the sense that in 1898, I don't think Heergaard was thinking about virtual reality and depicting different knots the way that the artist was going to be doing here. But the artist could look back to this dissertation from over 100 years ago and use stuff from that dissertation to a very modern end. So I felt like that was a very interesting part that showed the continuity of mathematics. And I really liked that section. Plus the knots were interesting, and it was really interesting to sit here and kind of puzzle out where you were going with each one. Page 73 had a piece of art. This is by Tiago Novello de Brito. But he has these interesting pieces. They're views inside 3 manifolds with their geometries modeled by Thurston Geometries. But actually what caught my eye were these little hands that were reaching throughout this bottom one right here. It brought to mind another art collection that I read that was also related to mathematics by Fomenko, and I think it was Mathematical Impressions. If you search Fomenko on my channel, and I will have it linked in this video as well, you can find his art, and his art was very bizarre and had lots of little people and things doing things within his mathematical art. So this just was a callback. I'm sure the artist had no intention of making a reference to Fomenko. My brain just found that connection in this weird little piece of art down here. Page 87 is the next one. And this is a piece of art that I've actually seen before. I don't remember if it was in that math art book or if it was a book I read in Geometry and Art in the Modern Middle East, but it's a example of stereographic projection, which I think explains how that works very, very well. So I'm not sure if this is just a very common way of depicting this or a very convenient way of depicting this, but I have seen this piece of art before, and I think it's just so cool no matter how many times I see it. And finally, on page 133, there's this piece of work which is showing rational points on a cubic surface. And this is the one I want to talk about in case maybe you're feeling overwhelmed or like you don't understand the mathematical concepts of this book. There's some glare, so I'm trying to show it. And he says this perfectly in the 3rd section, where he says there is some complicated hidden structure in the positions of these points. Understanding it mathematically is not easy, but visually one quickly gets a rough feeling for it, as you can see. Maybe you don't understand anything about distribution, but the brain, which is quite good at picking up patterns, quickly sees that there is some sort of internal structure going on here, and we can quickly get a rough idea of it without understanding any of the mathematics. And that's where I really want to make a point here, where this book discusses quite complex mathematics. These are people who are studying at some of the best universities in the world and working on very complicated problems, but in depicting it in an artistic way, they're able to make it so that we can get a rough idea of what's going on here, even if we have no concept of the math itself. And that's why I think these illustrations and these math projects are so powerful, because they can explain things that might be very, very complicated or beyond the grasp of understanding for some of us, in a way that we can grasp the rough idea of it without having to understand the math. Now, if you want to really understand it, you have to understand the math. I get that, but the art makes it very easy to grasp or get a good idea or a rough idea of what's going on just by having this depiction. And I think these artists in this book work really hard to have the interplay between math and art work in such a way so that they're not giving up any of the mathematical purity or truth of what's going on, but also have it in such a way that it's easy to depict and understand for someone who is coming in having never experienced that subject before. Overall, illustrating mathematics was a little bit more complex than I expected, but it was very enjoyable. It was a lot of unique pieces that I never would have expected, and so I had a great time reading it. I had a great time flipping through it. This is the kind of thing that makes me glad that people out there are funding ideas where different mathematicians get together and just get to model and play and illustrate mathematics in a certain way. It makes me very happy that people are doing that, because out of that meeting, out of that fall 2019 project, we got this cool book, which is very enjoyable. If you have read any of my other I say me as though I personally wrote them, any other books on math and art that I have reviewed and you thought those were interesting, you may also want to check out Illustrating Mathematics. I was impressed. I had a great time. Don't forget to give yourself plenty of time to read through the essays and enjoy each piece of art. And if you do, please let me know what you thought in the comment section down below. Thank you so much for watching, and I hope you have a great rest of your day.